like we have audio right off the bat this time. All right, let's get this little stream started. Let me make sure I have actual mouse focus on the thing that changes channels. Hi. So welcome back. This is just, I needed something a little less, less kind of intense with the preparation and the threads of thought kind of coming into and out of the particular experience. I wanted something more self-contained. Because the past couple of streams have been, collecting footage for these kind of more complicated ongoing projects. So we've been doing some kind of surface mount, soldering practice and stuff like that. Some of which is going into a video about board assembly, and so some of that's going to be just like little montages about ways to suggest practicing, and some of that'll just be here's ways in which I failed, and then go back and do it right and show people like here's how I did it the 18th time. Here's don't worry if you don't get this the first time. So there's been that kind of stuff, and we also built this face dancer board, which I am excited to do the next step in that, which is more kind of software involved, and it involves kind of reproducing this experiment that I did earlier in a different framework. So that'll be really interesting. I didn't really have enough time to dive into that tonight. I've only really got a few hours to stream at most, but I've been really wanting to dig into the next Boldport Club electronics kit. So that's what I've got on the menu tonight. And just to quickly recap, let me show what the last couple of kits were. I'm actually super behind. If you haven't heard of it, Boldport Club is a membership. Whoops, here we go. This is the channel we want. It's a, it's like an electronics kit of the month club run by Sarge Rimmer. And he does these circuit boards that are a really delightful combination of kind of art and functionality and entertainment and education. So this was the first one, and I did a full video on this kit, which is a sort of a type of oscillator and light sensor that's also an homage to a great analog engineer, Bob Pease. And then the second kit that we did was this cute little contraption, the engineer superhero kit. And so this was kind of interesting because it's kind of a different construction technique. So I ended up doing kind of a different video technique for this too, and making it kind of more of like a music video. And so this was something that took a lot of time to make, but then the video was like 3 minutes long, which was super fun. But yeah, it's not necessarily something I have time to do for all the kits, but it was great. I want to figure out how to do more of that. So in addition to just putting together that kit, and the idea behind this is that it's this simple little circuit that's kind of like a little MOSFET switch with an LED, but it's also kind of a little carryable doodad that has parts that you might find handy if you need to kind of MacGyver yourself out of a bind. So you can kind of take one of these out and use it to make something or attach something to this. And so in the video, even though it was only 3 minutes, I took the opportunity to make kind of a spin-off from that kit. So with this, I took that same circuit but modified it very slightly. You can maybe spot the differences. There's like a diode, and I changed this resistor over here. But then this 3D printed enclosure has magnets in it, so I can keep it stuck to my whiteboard. And then over here, there's a battery. And then over here, there's a little piezo. So actually, if you press on that, then the LED starts glowing, because the piezo, through this diode, charges up this little capacitor. And then if I kind of touch in the vicinity of the transistor gate, then I can drain enough of the charge off to turn it off. So I somehow fit the construction of this whole thing and the original kit into like 3 minutes. So anyway, that's why I'm very far behind on these kits. Yeah, I forget actually how far they're up to. I think there are like 8 now, and some of the later ones look really cool. I've been trying to do them in order and not, sneak glimpses ahead, and not, give myself spoilers, because I like the, the kind of experience of taking a look at it without having any more preconceptions than necessary. So I might as well actually roll this camera. If you haven't been on any of these streams before, part of the reason for the weird sort of format with the like viewfinder and all that is that in addition to live streaming what I'm doing, I'm also producing these kind of more in-depth edited together videos, and so I collect footage wherever I can, and then I obsess over it in Final Cut until a video comes out. So that's enough background. Oh, there's a question in chat if something like this could be sound sensitive. That would also be a really good add-on for this circuit. Because really, this is just a very high impedance amplifier. So it still needs a good amount of voltage to trigger it. That's why I have to kind of, it's a little hard to hold this under the camera in focus, but also trigger it. But yeah, you have to kind of give it some pressure at just the right spot, because it needs to build up a good amount of voltage to reach the gate threshold on this MOSFET. But other transistor circuits could be designed to be sensitive to a lower level. You know, maybe I could imagine a version of this with kind of a dead bug style, like op-amp even. Like maybe with a hole routed out of it and an op-amp chip fitted in there, soldered kind of on the end of the pins or something like that. So that could be really interesting. And then you can make it sensitive to something with lower input levels like audio. Or maybe there's some kind of mechanical megaphone you could add to amplify the vibrations. Well, anyway, let's take a look at this new kit. So, got our cameras rolling, and this is the kind of exterior view, which I'll probably just kind of cut into something pretty quickly. But I think the packaging has changed a bit over the course of the kit. Some of them have been more kind of flat envelopes, and I think the packaging, you know, Sarah's been tweaking the packaging to try to ensure the best survival rate since he ships these all over the world. But yeah, let's open this thing up and see what magic awaits us. What kind of interesting fusion of art and engineering might be happening. Oh, and I see my cat in the background. Usually the camera in the top right is Tuco Cam, pointed on my adorable little kitty, but he's been upstairs. Oh, this is the Cordwood puzzle. I've been looking forward to this one. So this is a really interesting kit. I know a little bit about this. It's modeled after the kind of Cordwood assembly style that I believe was first used, or maybe was popularized by NASA to get just a really high density of, you know, analog at the time, analog circuitry, and maybe very old digital circuitry into circuitry that was designed, you know, into equipment racks that were designed to fly. So really getting as much three-dimensional utility out of the space as possible by not just putting components on the board, but actually taking through-hole components and sandwiching them between boards. So, and I think this is a puzzle because it's not got instructions. So, I'm going to put these lights a little farther back. I had these, so I just got these little IKEA, what are they called? Janstro? I don't know how to pronounce it. I hope somebody else can correct me. But they're the little snaky lamps with the high power, you know, a couple watt LEDs in the end. And I might need to change the color temperature of my setup here, because so far I've had it more cool to match the color temperature on the microscope, and these are certainly warm. But having a nice point source next to the circuit board you're working on really helps bring out the small surface details a lot better than just having these nice diffuse lights. Oh, I was just catching up on chat. There's a question about whether I've done reverse engineering on smart card or NFC devices, and there's a lot of different I guess areas there. I haven't worked at all on the kind of more modern, you know, like 13.5 megahertz and so on, kind of cards that have, you know, more like standard smart card functionality in them. And there's a lot of work to do, and in fact, a lot of the techniques you might use with smart cards could probably be applicable there too. But actually, the only cards that I've played with myself are the low-frequency entry cards, the 125 kilohertz cards. And I just find those interesting to kind of mess with on an analog level. Made this weird thing a while ago where I could program this general-purpose microcontroller, just an AT-Tiny, with this program that was actually clocked by the carrier wave on the 125 kilohertz signal from the RFID reader, and then the program would actually just use the GPIOs to modulate the current usage of the microcontroller to then transmit the signal back. I don't think something like that would work at 13 megahertz. Maybe on a CPLD or something, but then you're just implementing an RFID card on a CPLD, which maybe is actually pretty easy if you find the right CPLD. Oh, it looks like I'm going back to back against EEVblog. They're also streaming. I'm going to have to keep this interesting. So here's the Cordwood puzzle, and just to make sure I get a good wider shot of this for context, because I was in pretty close. Got another sticker to spread the word. I might want a close shot of the sticker too. I didn't realize EEVblog did streams. I usually watch the new videos on his main channel, but I haven't. I don't know if he's been streaming on the main channel or another channel, and I don't really pay attention to the other channel or the forums. And I occasionally hop on the forums, but it's been a while since I've really been able to check forums regularly, even if it's a forum that I'm pretty into. All right, Cordwood puzzle. Let's see. It's pretty stuck. Oh, there we go. Oh, big chunky parts. There's the circuit board. Ah, yeah, this circuit board. So if you've seen any of the, especially I guess the earlier Boldport advertisements, this circuit board probably showed up a lot because it's really beautiful. I mean, most of SAR's work is just really amazing, but like, it's pretty unique. It's just nice. Nice seeing a board that just, you can tell it's electronic and it looks like it should work, but just doesn't in any way look like a normal circuit board. Let's see if I can get a close-up on the end here. I'm going to bring the camera in a little closer. Oh. Guess from the chat, EEVblog was having like a special giveaway event. Let's see how close I can get this and have it still focus. Oh, so how's everybody's Friday night? Is this going to be like a good hacking night for folks? I've been working on all this really, I don't know, stuff that's like, where you can like tell that you're making progress, but not in a way that's really satisfying. And I think that's part of why I thought putting together a kit would be nice. Yeah, I've been working on this glitching setup on this processor, and I'm trying to figure out whether I can. There are parts of this setup that I can share live because I think it's pretty interesting. But yeah, just annoying stuff like hitting limits in what my equipment can do here, and trying to determine the difference between the LDO oscillating versus the processor actually executing code, and and I think I've found solutions to a lot of the little problems that were bogging me down, but it's just you know, it's nice to make the amount of progress that you want to make and not substantially less than that. I think that's a common feeling in the technical pursuits. You're always fighting against realities that you haven't quite got your head around. And for me, I guess some of that is just in this case, it was an understanding of just the kind of orders of magnitude of impedances and currents and things involved. And this processor just, it has an internal LDO regulator that I was fighting against. And being a much faster processor than I'm used to working with, it has, a higher current LDO. So I think I might need to put the MOSFET a little closer to fight against it effectively. It's probably enough angles of this single board and getting distracted by the way that it's so shiny. But let's see what else is in here. So we've got some of these beautiful resistors. Make sure I started the microscope recorder because I might get some of this under the microscope just for amazing texture. So I think that's the contents. I think we've got, yeah. So we have these two boards, which look similar. I don't know if they're the same. Looks like there's, yeah, it looks like they're the same. So, I mean, that would make sense if you could design the puzzle to use identical boards. It would be more economical. I'm going to make sure that the recorder for the microscope's going, and then let's get a closer look at these. On my wish list for this setup still is like a way of monitoring whether all my recording doodads are actually running from over here, because I've got another computer recording the high quality video and managing all the audio, and I can't really see what's going on, so maybe I just need to move that monitor closer. Oh, there's a comment from the chat that somebody's seen this board from Hackaday, and yeah, I think I'm pretty sure Hackaday has done an article or two or four on Boldport and Sargrimmer, and yeah, this was one of his kind of earlier, more famous designs from what I know, and so yeah, isn't that great? I love those two traces together. So part of why these boards look so interesting is he designs these using his own software that lets him do all of the work in illustration tools like Inkscape instead of using traditional PCB design software. So he can just draw these traces using vector software, but he still has a Python script that handles the kind of manufacturing details, like the spacing between the solder mask and the pads, and the clearance around the holes and things like that. So my cat's back. Yeah, cat cam is enabled, and Tuco, I think, was hanging out upstairs, but he just came back, and now he's actually, oh, he's behind the monitor here. Let's see if I can get him. Hey, Tuco, wouldn't it be more comfortable over here on the chair closer to the camera? Can you see him? Hey, little guy. What do you think, Tuco? It's an electronics kit. Yeah. It's all good. Oops. Hey, Tuco, you want to hang out over here by the heater like you usually do? No? Oh man, yeah, I need like a robot cat butler. Just ideally, I wouldn't want him to have to wear anything while he's in the house. I have Tuco wear a collar when he's outside. Hey Tuco, do you just want to play? I'm doing a stream right now. I can throw the bolt though. You want to play? Oh man, that is a huge yes. He totally wants to play. see if I can get a better angle of Tuco. Oh man, the perils of cat ownership, getting distracted from a cordwood puzzle. Hey, Tuco. I hate describing pets as being owned, though. I think of him as, this critter that I take care of. Because he's had opportunities to leave, and I mean, clearly there are incentives for him not to leave, but he also seems to like it here. Oh, the camera thinks I'm not doing anything. No, it just reached 30 minutes. All right, let's see if we can get a little farther into this. Oh yeah, there's a discussion in the chat about these streams making good kind of background for working on stuff in the shop, and I totally agree. That's how I like kind of YouTube streams and Twitch streams and long videos for that kind of thing too. The videos that I usually like to make are, I do this thing that's very, very dense and maybe hard not to pay attention to in some ways, but then I also like, personally, I really like watching stuff that's a lot lighter while I work and just not necessarily paying that much attention to it, or, having music on also. And it's just nice. I don't know. I've heard it called parallel play in kind of psychology circles, just kind of being around people doing similar stuff, and not really interacting that much, but kind of interacting some, and I like that a lot. It's kind of my speed when it comes to getting enough of a social hit while still being able to concentrate. And in some ways it kind of helps concentration in some of the same ways that background music helps, just providing almost like a clock signal for what I'm working on. Oh man, that trace is great. That's really nice. I'm really into that, I don't know which terminal that is on the transistor. I assume I'll probably want like a look at the data sheet to figure out which one's emitter, base, and collector, but I mean, I assume that's probably like an emitter if that's like an NPN, but I guess we'll see. That's great. All these little polyhedral pads, they remind me a lot of the a feature that you would see on more traditionally designed circuit boards called copper thieving pads. You don't see them much anymore because modern PCB fabrication processes, for reasons that I don't understand, don't tend to need them as much. But it used to be more common that in order to balance out the amount of copper that you were etching chemically from the different surfaces on the board, you would want to, if you had big blank areas, add some little squares in them just to kind of keep the etching rates more uniform across the surface of the board. Yeah. Do I want to have this portrait or landscape? I guess this almost perfectly fits in the field of view vertically in the microscope at this angle. Of course, pretty much any kind of motion makes stuff like this very hard to see. So, it's like part of me wants to do like a panning shot across this and then edit that in some way, but unless you actually stop or come extremely close to a stop, you can't really resolve detail unless the video is much, this is like an interlaced 60 frame camera, so if I move it around a lot, especially with the compression that the grabber is going to do, you're not going to see nearly as much detail. And then moving it slowly is also kind of hard sometimes, and I think right now I've just been like pushing my fingers against this glass that I have, which is, I like the glass because it's easy to clean the gook off of and make the surface smooth for motions like this. But Yeah, I had some videos before where I had this crazy thing rigged up with a disco ball motor to try to move things smoothly. And it kind of worked, but it made me really want to get some kind of stepper motor-based motion control thing set up. And I don't even know if stepper motors by themselves are what I want, but maybe this brings me back to the idea of wanting a little DIY servo motor based on three-phase, like brushless motors. But yeah, I'd be really curious whether stepper motor with feedback, something like the Mechaduino, would help with that. All right, let's see what else we've got. I'm getting very into these single parts here. Oh, yeah. Bring the microscope to the front and restart the DSLR. Oh, yes, those are both great suggestions. Thank you. I think part of the problem here is the laptop is way too far away right now. I'm just going to blame that. Yeah, microscope to the front. Where is my remote? Oh, remote control. Great. Microscope, DSLR. Great. Thank you. Sorry about that. There we go. And can we get Tuco Cam going? Hey, Tuco. Great. All right. Oh, we got some good angles going on there too. So, I think this board is going to be all about the third dimension. So maybe having a bit of that, even in the very earliest shots of this, might be helpful. But that's nice. I like the squiggly traces. And so the connectors we've got are interesting too. We've got these two pins over here which seem to have a couple of different forms they can take. Well, these seem to be for cordwood style components sticking out. But then this looks like it could either be a surface mount or a through-hole kind of wire harness kind of connector. And maybe a mounting post. And then over here, a similar kind of connector, but with more pins. All right. So let's take a look at these components. I think the other thing that made this kit really so picturesque is just these amazing giant resistors and LEDs. Oh, and is this special wire? I think this might be special wire for going in between the boards. I mean, maybe it's only special in that it's, a particular gauge and it isn't insulated, but that's the wire that is intended for that, I suppose. Hey, Tuco, you gonna sit in the chair? Meow. Hey, cat. How are you? Oh, yeah. Okay, so now we've got standoffs for the giant holes there, which are nice. So mechanically separating these two boards, and they're about the same length, a little longer than the resistors. And we've got these enormous, beautiful LEDs. And this looks like a capacitor. Let's take a look under the microscope. 105, so I think that's a 0.1 microfarad capacitor. Let's see if we can see the other side. Let me bring the microscope, sorry. I didn't have that DSLR view last time, and so I spent most of the time on the microscope, but now I'm forgetting to switch back. This is great. It's I was thinking recently, soldering these surface mount capacitors, of just how much some future civilization is going to be writing a report on the ceramic output of this century, and it's going to be all about how all of the colors are drab, and we're just painting all of our ceramics yellow and laser etching these simple numbers on them, whereas previous centuries had these amazing artworks they would put in their ceramics, and they had these giant ceramics that were on display for everyone, whereas we just have these tiny things that we hide inside of our electronics. But I don't know, if you want to see somebody being more excited about their ceramics, I do appreciate some of the videos Murata have about their capacitors. Because it is just like a big factory that makes like sheets of little ceramic cookies that go into just everything. Anyway, I think that's enough photographing the capacitor. What else do we have in here? Go back to the wider view. Oh, there's a good question in chat about whether I am planning on adding chat into video. And I've thought about that. I think at the moment, the biggest problem I have is that the computer that's doing the chat is, sorry about the crinkling. The computer that's doing the chat is so overloaded right now that I don't know if it could handle like a browser plugin running in OBS at the same time. But maybe there's a way to do it without the whole browser plugin. Also, I'm only running the stream in 720p, so I don't know if there'd be a lot of screen space to have the chat be legible. But that's something I'll definitely I'll definitely try that once I have some CPU to spare on that machine. So I've been thinking about upgrading. Once I actually do that, putting the chat in the video would be really nice. Or if you have a suggestion for how I could do it without overloading the stream machine too much, that would also be really nice. So it looks like we've got some really nice hardware. Oops. Let's see. Got some really nice hardware, these really cute little screws. Let's pick these up with the tweezers to get them on video. Yeah, some nice little screws. Good flat profile. Yeah, this kit has a really interesting aesthetic to it. Looks like, I haven't looked at all the transistors so far, but the ones I've seen so far are 2N7000, which is like a really garden variety MOSFET. Let's see how much closer this will get. Oops. Let's get a close view of the microscope. Yeah. Cute little 2N7000 FETs with more laser engraving. Got some buddies here. So, I was curious actually whether part of the puzzle was going to be figuring out which parts needed to be populated, since I thought maybe with having two of these boards identical, maybe some of the components would only show up on one board or the other. But there are, it looks like, 6 transistors here, and 6 total locations for transistors, and they all seem to be 2N7000s. So yeah, the invocation on the package that this is a puzzle and the assembly guide is missing, my first thought is, oh, I'd better drop a schematic. But I think actually they've made this pretty unambiguous, except maybe for the LEDs, but you know, I guess if I wanted to cheat, I could look at the photos of how these are put together. And I know in the past that's been useful. Because otherwise I don't know how I would know what color goes where unless that's just up to me, in which, you know, that'd be cool too. But let's get a reminder of the pinout of this transistor and then just take a quick look at how these are wired. I'm going to make sure the computer recorder is going and then I can pull the pinout up on there. Computer time. Hey, Tuco. Oh yeah, there we go. Good camera. All right. 2N7000. Small signal MOSFET. Oh, why do we have 1, 2, and 3 there? Okay, here we go. So the flat side facing you, it's source gate drain. So let's see what that means for this circuit. Oh, does this help? Oh, tiny bit larger. There we go. All right, so we've got 6 of those. All right, so source, gate, drain. So these are N-channel, which means that the typical way you'd wire these is with source connected to ground, gate connected to a roughly logic level control signal, and then drain is what gets pulled toward ground whenever the MOSFET is switched on. So in this case, it looks like this left rail is our ground, and just like I guessed earlier, it looks like these nice kind of outlined traces are the ground to the source of the transistor. So each of these boards has 3 transistors, starting there, there, and there. And so far this trace on the left has just been a common source for all the transistors. And that goes here. So it would make sense for this to be like a negative battery terminal. And then let's see, what if this is positive battery? So we've got a couple more components where it can connect vertically. And whee, all the way around here. So, oh, that's interesting. So those will connect vertically through a bunch of resistors to the other board. And will, I assume, just end up, those resistors will end up in parallel, and you'll be joining the positive rail of this board kind of loosely with the positive rail of the other board. Unless you flip the two so that this is going to this on the other board, that might make more sense. So if the two are flipped relative to each other, then this one's connected to that on the other board via a resistor, and this is an LED. So that presumably would be the positive side of the LED, and that would be some resistor to limit its current, and then that LED would be pulled down to ground through this transistor when the transistor's on. And so what turns on the transistor? Well, this would be pulled up through a resistor from the opposite side, and then where else does that go? It's also connected over here, So it looks like what happens is when you put two of these together, kind of reversed 180 degrees, so they cross over when they're with resistors, then you connect power to either board and they both light up, but then you can ground these pads, well, not those pads, these pads here. Oh, gotcha. And if you connect wires through here, connecting the boards, then assuming those aren't connected on the other side, yeah. So that's what this is for. If you connect wires through, then when you just power it on this side, and in fact, these could just be for through wires if we're following the pattern here. So if these are just for wires connecting the two sides together, then these could also just be for wires. And now you're not relying on the resistors to connect the positive rails, which makes sense. And then, yeah, and that makes sense too, because there'd be like, if the boards were mirrored. So then, what do we have over here? That couldn't be, so I don't know what these two pins are for. But anyway, the connector up here, when they're all wired through, it looks like that would be a way to, you know, by default these lights would all be on, but you could ground these inputs to turn them off or connect them to a microcontroller, and this would be a logic level display. So that's cool. I can just put the LEDs in whatever color order I want, I guess. Well, I guess it would make sense to start out by putting, you know, all the kind of non-Cordwood style components on. So like the transistors definitely, and probably the LEDs too. So the computer I'm using for the stream is actually pretty overloaded right now, and it isn't just it isn't just like one encode or one screen capture. It's a combination of a bunch of things. It's like it's encoding the stream, and it's got two 1080p 60 frame per second inputs that it's got to deinterlace, and it's got to decompress video coming in from the Mac Mini. And you know, it's got occasional motion JPEG streams it receives when I have the camera on the robot. So it's, I don't know, it's just one of those things where it's not just like one simple thing, but like every scene in OBS I've had to optimize it so that it runs at 30 frames per second just by like cutting down on the pixels when I have to. And you know, and it's things like the DSLR. I'm doing all this like chroma keying and stuff to make the menus mostly transparent. But that gets expensive for some reason, whether it's doing it partially on the CPU or whether it's hitting like a slow path on the GPU on this machine, I don't know. But it's faster if I downscale that video before doing the chroma key for some reason. So, I mean, I think that just points to which portions of the system are overloaded right now. And the load's pretty well spread out. I've got the hardware H.264 encoder busy, and both of the CPUs are busy, but yeah, let's get a vise and prep this for some soldering. Oh, and there was also another software-related question in chat. These are all going to roll away. There was a software-related question about PCB design software. And I don't have like one good answer for that, because I think right now there are still a couple of different options to consider depending on like, you know, who you are and what work you're doing and how much money you have to spend and how much time you have to spend. And you know, I've used, not anytime recently, but ages and ages ago, I used some of Altium's software with like a student license, and it was really, really nice. It was like the first time I'd used PCB software that didn't just completely drive me crazy. But then, you know, it's also super expensive if you get a license, and you know, you get a lot of nice things for that. You get, you know, all this kind of tie-ins to different kinds of design software, and you get like an auto router that mostly kind of works, and you get the ability to actually handle like large designs without the screen redraw just flickering like crazy. So there's a lot that's good about it. but really expensive, not even slightly open source. So, and then lately the kind of de facto standard tool for kind of hobby and maker kind of design has been EagleCAD, and so it's got a bit of a learning curve, but it's fairly nice and it's relatively powerful, and it's not open source. It has kind of a restricted free version, and you can get a fairly unlimited version that isn't going to be that expensive for people who are doing a lot of electronics work relative to other tools that you'll need. So EagleCAD has been a pretty good option for a lot of people, and as a result, there's a lot of existing resources for it. So, part libraries, especially like SparkFun and Adafruit, both have huge EagleCAD libraries that you can use in your own designs. So that can be really nice. I've been really liking KiCad because it's a fully open source alternative to these other ADA packages, and it's also been it's been quick to take some of those features that have previously been really premium. Like, I really like KiCad's push and shove auto router. So it has a way that when you lay down traces, you can then kind of interactively push them around on the board while still preserving all of the electrical spacings that you need. And I used that exclusively to make this circuit board that was pretty complicated and just like really intensely dense for a 2-layer board, and just found those tools really uniquely well suited for that kind of work. But then I found myself with KiCad doing a lot more of the prep work, so the footprints and just making all the libraries. I had to do more of that myself, and it was a little more quirky to learn some aspects of it because it's just the UI wasn't quite as, I don't want to say polished because I don't want to say Eagle is at all polished, but it just wasn't, like, the quirks weren't as well understood on the internet, I guess. But that's been, I think part of the reason I like KiCad is that it's been getting better really quickly. So I guess my advice is, unless if you're like really pro and you just want something that is super, super great and you don't care about money or openness, then maybe get Altium. If you want to take advantage of that huge existing ecosystem to really get things done quickly, and you don't really want to have the patience to adopt something new, then maybe try Eagle. If you're really into open source software, or you just do have the patience to try something that isn't necessarily going to be the most well supported yet, but is still coming up really quickly, then I would definitely recommend you try KiCad. So yeah, that's my 2 or 3 cents on circuit board software. Let's make sure we have the DSLR going. There's another question in the chat about a software called Sprint Layout. Very popular in Russia. I haven't heard of that at all, actually. But I'm not surprised. I haven't really gone out and done like an exhaustive survey. I've mostly just been I think the software that I used in the past was mostly just whatever I could get and whatever seemed, whatever seemed easiest to use at the moment. And then when I found kind of some viable open source packages, so like KiCad was the first time I saw something open source, and I was like, oh, I definitely want to use that for my own designs. So then that became a factor, and I wanted to support that. But yeah, I haven't done like a really exhaustive test. I remember trying some like, in like I guess the mid-90s, I tried making PCBs at home using some software in DOS, and I think I ended up giving up on that and doing a lot of it with rub-on stencils instead. I might have gotten the DOS thing working. I forget what board I would have used that for. I think I had some kind of IR receiver set-top box VFD thing that I was doing, and I etched a board for like a little PIC microcontroller doodad. Totally the kind of thing you would just throw an FTDI chip at now. Oh, I just noticed a question in the chat about what this is. For people who are just joining, this is an electronics kit from Boldport Club, and it's a monthly kit service kind of thing. And I'm pretty far behind. This is the third kit, and it's been going, it's like on the 7th or 8th now. So, but I've still been kind of trying to do them in order and not spoil myself on them. So, and so with the streaming, I'm hoping I can actually maybe catch up a little more, because even if I don't have time to, edit all the footage into something like super polished for every single video like in order, I could still like do the assembly in order and stream them, and then maybe have a little more freedom in the video editing to, find different formats for each video based on, what would seem to fit it. Let's see if I can get like a steeper angle for this. I don't know. This directly up and down angle is not so great for any of this. I think I can rotate this microscope a little bit to solve that. Shoulder cam. So that's loose. This is the jankiest microscope stand, but I like it. So it's just like a light stand and a clamp, but it has a really long reach, and because it's attached to the desk, it doesn't wobble as much as something that isn't attached to the same surface it's filming. Let's see if that helped at all. It's a little vertigo-inducing. Maybe that's fine. That's better. Let me switch back to the microscope, sorry. Yeah. Move this a little farther out of the way. Oh, there's so much stuff on this desk. Okay, so now we have focus there. Can I focus all the way up there? Yes. All right. Some 2N7000s. Now, I think what I'm going to do on this is, let's first just try to place all the transistors and see if I can get them placed consistently before I solder any of them. And then I might do these a little bit strangely just so that I can get the best placement, just for, silly aesthetic reasons, because these are, these kits are so much about aesthetics that I can't help but be a lot about aesthetics when I'm putting them together. So I also need to figure out which of these resistors go where. These look like, what is this, 10 ohms and 10K? I'm going to check that just in case I read these wrong, but I think that's what we were dealing with. So I think to get the best placement on these transistors, I might get them lined up while I have the circuit board in the vise, and then actually solder the top sides, and then clip the bottom side so that only a little bit is sticking out, and then do a solder dome that covers up the end of the leads so that it's nice and smooth on that side. Let's get the other camera positioned a little closer in now. Oops. Yeah, this direction is definitely better. And you can see the label. 2N7000. Oh, there's a question in the chat about whether I know antennas well, and I'm afraid not. I have never really built an antenna. I kind of sort of understand the theory, sort of kind of, but I'm sure I couldn't really do anything practical without doing a bunch of research. It's something I've been interested to learn. Like I still have only really slightly dipped my toes into the analog world, and I've built a bunch of stuff with op amps, and um, I like making kind of low-speed analog filters and stuff like that, and stuff with like peak detectors and capacitors, and trying to solve problems creatively with simple circuits. I like that kind of thing. But I haven't really done much in the RF spectrum because I tend to be more into stuff that I can really see the inputs and outputs clearly. And until recently, I haven't had equipment that can measure RF at all, really. I only recently got an oscilloscope that gets gets up into 100 megahertz. I think that's about where I want this. So I can zoom in about that much. I think I actually want to center this on where the microscope's centered, though. I really like this magic arm, but it's not amazing for fine adjustments. So usually I try to position it somewhere and then do the fine adjustment elsewhere if I need to. But I think that's fine because I don't think I'm actually going to be zooming quite that far in. Cool. Oh, there was another question in the chat about streaming design and reverse engineering work, and that's totally going to happen. Like, I think this is just what I was in the mood to stream tonight because I didn't have a whole lot of time to devote to it, and because I've been doing so much of the kind of more frustrating reverse engineering stuff recently for work in a project that I can't share quite yet. But so this has been a nice kind of palate cleanser relative to the other stuff I was doing. But in fact, the other thing that I've been wanting to stream, like next time I get a chance to stream, so probably tomorrow, is kind of a continuation of that project using the face dancer, which is sort of that USB device emulation board to, I really need a better view from the DSLR here. Using the face dancer to emulate a debug dongle for this particular processor that I want to disassemble some code for. So yeah, that's going to be much more like software and kind of reverse engineering, kind of like trying to understand the innards of a system by building a fake version of its environment, that kind of thing. Oh, there we go. Focus. Let us not autofocus this shot. Autofocus is not doing me any favors. Oh, if I can go back to running Magic Lantern on this camera reliably, it would be really nice to get focus zebras. Or whatever you call those when it lights up where the focus area is. But like with the HDMI output on this Canon, part of the problem is, like, it isn't just that there's like an overlay on the screen, it's also just not very high res. Like, it's a 1080p signal, but I think that's because the UI from the camera is being upscaled to 1080p from something else. And I think it's actually just whatever resolution the camera LCD has, which is not as much as whatever the sensor's capturing. All right, let's start here. Oh, do I trust autofocus? Maybe I'll let autofocus get that set up. Oh, focus peaking, yeah. All right, you can just stay stuck there. I forget whether there's a button you can push to do a momentary focus when you have it on manual. Like, if I push that halfway, no, I don't think that works. Yeah, I don't know. I don't know a way to do that other than momentarily switching on the autofocus switch on the lens. But that works. Let's go ahead and restart that, because it's about to switch. 3 files. Alright, those transistors are definitely on the right side of the board. Sorry, I made it very clear which side of the board is the component side on this. And somehow my soldering iron is still cold. That's terrible. Well, maybe while it's warming up, I will just try this again. It is off. And now it's on. Yay. I really like how fast these heat up, though. This is the good old WES51. Oh, there was a question about the camera magic arm. If there's a ball head on the end, it has ball heads on both ends. I don't have like a separate add-on, but like the way the magic arm is built, it has like an elbow that moves with 1 degree of freedom, and then it has these spherical joints on both ends of the arm, you know, away from the elbow. And then they have little cutouts that kind of restrict the motion a little bit. I don't know quite why they do that, but I think it's just for rigidity. And it's pretty good. I've been super happy with that. I mean, it has its limitations for sure, but it's improved my ability to get the camera where I want it just a huge amount. Just completely changed the way I set things up, because it used to be I would put the camera... Oh, that's what I was doing. I had a cheap tripod that I would clamp into a light stand. So it was kind of similar, but it was much harder to adjust. And anytime I adjusted it, it was a big production to get the camera steady again. I'm going to tack down the other side and then go back and do a more solid joint with better focus. There's this noise outside that I can't track down. Well, I assume it's outside, and I haven't actually gone outside to look for it, but it's one of those things that sounds so much like electrical interference that I keep assuming it's coming from something in my shop. But even when I turned off all the speakers and, you know, it didn't go away, and I put my ear next to all the equipment that might be humming in some way, and it didn't get louder. But it sounds so much like an amplifier processing. Like, I guess it reminds me of the ground loop interference I was getting on this streaming setup before I put ground loop isolators all over the place. And every time a packet went through from the HDMI grabber with all this compressed video, I would hear that packet encoded into the audio stream on all the other compressors. And it was really loud too. It was not a subtle artifact. That's one of those things that is still frustratingly expensive to do in current electronics, is to provide good galvanic isolation, because you still need somebody to, you know, not wind a coil usually, but at least like take the coil off the machine and like orient it properly and stuff. Like, from what I've seen, like coil manufacture still just involves a lot of steps, and some of them have to be kind of manual, and I've seen more modern ways of accomplishing that, like with, I think it was Murata that is doing a little surface mount power supply cube thing that has just like a really, really multi-layer circuit board and lots of tiny vias connecting the layers, so that the circuit board itself can actually act as a pretty good switching mode power supply inductor. So that seems pretty cool. And, if technology like that gets to the point where, just any board can just stick that on there and have a good audio transformer. But, audio transformers are a lot more demanding because you need to be able to pass lower frequencies with low distortion. So having a PCB audio transformer still seems a little science fiction-y, but I really think PCB technology is going to start changing pretty significantly in the next couple of decades, really, to much more three-dimensional layouts. And so once we've got more of that, then maybe good circuit board inductors and transformers start becoming cheaper. All right, so let's take a little bit of a aesthetic look at these. I got a little bit of solder on a leg in a way that I think was not so pretty. I want to see if I can get that off. That one I think was fine, but yeah, let's stop. Let's get that off. Oh, let me switch back to the microscope because that's what I'm looking at right now. Oh, that probably just needs flux, but I don't want to add flux if I don't have to. But that probably just needs flux. Okay, I'm going to stop obsessing over that to the extent that I can. I think it's probably okay. Those look fine unless I'm looking at it under the microscope. Under the microscope, they're almost fine. So the other side now, a little bit of solder wicked through there, but for the most part I haven't soldered this side yet. My intention is now to cut them pretty close to flat and then give them little solder domes. Ooh, good reflections. Yeah, these are nice circuit boards. I know Star puts a lot of care into the circuit board process and has a pretty good relationship with his manufacturer. So I'm trying to give it a little bit of clearance there because if I cut it just completely flush before soldering it, then the surface tension will kind of prevent it from being a good solder. But I think if I leave just a little bit, then I can make it into a pleasing little dome without it being a risk of a cold solder joint on that side. And honestly, it doesn't have to be connected on that side because we have plated through holes. I've gotten a little used to working with non-plated holes lately. But yeah, and so we don't have to worry super much about them being long. That's a good length. Oh, Tuco's getting a good nap. Yeah, I really enjoy the idea of like taking the boundary between circuit board and circuit design and components and collapsing them a bit more. Because right now, I don't know, I feel like I see such a big difference in mentality between software and hardware. With software, there's all this potential for people to get like not invented here syndrome and just like want to build everything from the ground up. And goodness knows I've spent a lot of time doing that. But then on hardware, that's like you can kind of do that, but it's just really, really like quickly apparent how impractical that is to do anything real. So then a lot of hardware just ends up looking more like, well, how do I connect the little blocks together to get the thing that I want? without necessarily having to understand the fundamentals or without that necessarily being as useful. So, I don't know, I like stuff that kind of keeps it real, where, you can work at a high level of abstraction, but, it still benefits you to understand the details. And that's part of why I like, trying to do things that people wouldn't normally do with hardware, like reverse engineering it, or trying to, do weird stuff on underpowered CPUs. And so I like finding excuses to solve problems like that most people would avoid. Those look a little long. I'm going to trim those slightly more. I think somebody mentioned on a previous video comment that they like appreciated the video, but they were also noticing that it's kind of frustrating to watch someone else do this like detailed fiddly assembly when it's something that you're used to doing. And I have to totally agree. I mean, I like watching these videos, but I also, I also totally feel some of that. It's like, I think anybody who's like a backseat driver, like, if you're used to, driving that race car, then you don't want someone else driving, because they're gonna do it wrong. But I think it's also helpful to kind of sit with that feeling and get past it, because, if, as much as I feel that, I try not to, to let it out when I'm around people who are new in the field, because it's like really, really unhelpful for other people. So yeah. Oh man, these are not going to produce nice little domes unless I add flux, so I'm going to do that even though I'm going to have to clean the flux off. Yeah, I definitely like, I think one of the other channels I like having on in the background for kind of electronic-y stuff is Big Clive. Like, just watching him like reverse engineer like dodgy lamps that he orders online is kind of relaxing sometimes. I can kind of listen to him talk about that kind of stuff while I do other work. And I'm not sure why I'm getting such a dull finish there. It looks almost like this is lead-free solder, but it's not. I wouldn't use lead-free. That would just be inhumane. I'm still getting kind of this matte finish. I think that might just be the solder is still sinking into the hole as it's cooling, because I don't necessarily want a huge amount of it to wick up. So that's fine. I'm not going to worry too much about the finish as long as they have a smooth shape and they won't snag stuff. As I say that, I obsess over this one joint. Okay, let's make sure that didn't mess up the other side, and then do this to the other board. Oh yeah, I like that side view. Even though this microscope is not so useful for actual 3D work as a stereo microscope, I do like getting these kind of narrow depth of field angled shots with it. Alright, I'm not going to clean off the flux just yet. Let's do this other board. Oh yeah, Big Clive has a great voice. And yeah, just so much of his environment is charming. Being on an island where it's always cold, and he has a big beard, and he he's into all these really weird things, and I like that. Oh, it's so hard to get them all in the holes on the microscope. There they go. Oh, once we have that voice synthesis technology that's like coming out soon, then we'll be able to start replacing people's voices on podcasts. Do you think more people would watch EEV blog if we could replace Dave's voice with Big Clive? It's so easy for these not to all be exactly the same height. Actually, there's an easy solution for that. If I use something flat. How well did that work? Pretty well. A little bit less tallness. Slight decrease on the tallness attribute. Anybody else do Homestuck here? I don't really anymore, but I was in this long relationship with a Homestuck fan, and so I briefly got into it myself. And then we would make all these jokes around the apartment about the tallness attribute and how it keeps happening and things like that. All right, that's totally fine. Let's do some soldering before I just, totally obsess over that particular detail. Oh, what a Bobby Dazzler. Yeah, how do we do that with Big Clive's voice? That would be great. Oh, I hate when this glass surface plus the stick vise is really nice and smooth when it's laying down all flat, but if you don't get everything like totally flat and level, then it just kind of wobbles in this way that's super annoying. That kind of fixes it. Kind of means I should probably put like a little bit of felt on the bottom of the vise. That might give me the amount of friction I'm looking for to keep the movement smooth. Oh, I've been thinking about a soundboard, because I mean, I'm already using Ableton to mix all the audio for the streams and do the recording, so it'd be really easy, and I have like some MIDI devices that would be really easy to hook up. Yeah, we need the Bobby Dazzler. We need I don't know. I guess I feel like I have complicated feelings about making fun of other YouTube channels. Like, I totally want to do it, and I want to find ways of, kind of poking fun at other channels, but only if I can do it respectfully, because, I don't want to be like just a turd on the internet. I want to, I want to do things that are kind of funny and indicate mutual respect, even if the result is just, people kind of laughing. So I guess maybe I just have to make sure that I make jokes at my own expense and that I include. Yeah, I guess that turns into a question of like, well, what subset of another personality do I want to kind of turn into a little meme for my own show, basically. I guess folks like Dave and Clive are already pretty memed. Like they, I don't know how that happens. Like if you just get to a certain size and the memes just kind of automatically happen, or if they kind of cultivate those bits that are distinctive. I still don't know really quite how I ended up with Tuco, but it's pretty amazing that I did. Oh, it's so nice to have a solder mask. Like, it keeps the traces on the board and the solder doesn't stick to them. It's so nice. I've heard of boards with DIY solder mask. I forget how it was done. Like, I'm sure there was an article on it or something that I saw recently, but I don't remember off the top of my head. But it was some kind of like photochemical mask process like you would expect to see. Oh, cool. There's a project from the chat with an ISA card. That was something where back when I had a computer that accepted ISA cards, I always wanted to make something, but I never really, like, by the time I got good enough at just like generally building like larger scale stuff and digital electronics, like by the time I probably could have built a successful ISA card, I probably had a machine with only PCI slots. And then, of course, I got interested in, oh, well, how would I make my own PCI card? But that gets much more complicated. I guess the first time I actually made my own, like, I still haven't made a hardware PCI card, but I've done my own virtual PCI devices, like at VMware when I was working on device virtualization. I worked on virtual PCI stuff a lot. And it's just memory, or stuff that's pretending to be memory. Stuff that's pretending to be many different kinds of memory. Oh, Tuco is so napped out. Oh, another good comment in the chat that DIY solder masks can be done with UV curable paint. I have to imagine that would be like the stuff you'd use for like stenciling logos onto things. And I don't know if they use UV for like t-shirt silk screening and stuff too, or if that's all just air dry. I really like UV cure. I recently got some UV cured adhesive just to use for random stuff around the shop. Actually, originally for bonding glass to glass, because it's super good for that, and just like use a little AA powered ultraviolet LED flashlight, and it's nice stuff. Actually, that's also what I ended up using to make I made these little buttons on this this little remote. I guess I have the autofocus turned off, which is good to notice. It's the thing I've been using to change the channels on the stream, and I built up these little bumps which aren't really in focus, but they look terrible anyway because they got some like lint in them as I was cleaning them off. But I put there you can kind of see them, little bumps of that UV cure adhesive on here, and then cured it. It gets a little rubber nub on there that you can feel with your fingers. Right. So I think this required flux. Let's do the flux. And then I guess I get to decide what color the LEDs get to be where we have yeah, red, green, and yellow. Those are some good classic LED colors. And we want some more solder on these. With this pattern on the silkscreen, the downscaled digital SLR viewfinder is especially noisy. Oh, there's the comment in the chat about virtual PCI from Kay Timken, who says they've spent a lot of time writing and hacking on device models in Zen, and it's simultaneously a lot of fun and absolutely maddening. I wholeheartedly agree. That pretty much sums up my experience at VMware too. Depending on the device, there were quite different kinds of madness. You know, the really old devices, the madness was mostly just in accommodating like every possible weird kind of broken operating system quirk that you could imagine. Some of my favorite accommodations like that were just like bizarrely low level, like oh, so here's a good one. We've got a virtual, well, I say we, that's, so way back in the past when I worked on that, our team occasionally had to maintain the VGA emulation, which was mostly just one of those things that like people had written years ago and didn't need much maintenance, but you know, I was kind of one of those people that often tried to shake things up and change architectures and introduce new broad changes that required a lot of the old stuff to change as well, for better or for worse. So, oh, I didn't notice I was sliding this around in my vise and bent the transistors a little bit. I'll have to bend these back into place. Yeah, we had all this like super old emulation code for VGA, and like VGA is, I think it's just such an amazing collection of legacy emulation quirks. And if you haven't, you know, if you haven't been exposed to, you know, so like a thought experiment, if you like boot up a PC that doesn't have any kind of graphics drivers, then well, the first thing you see is a text mode coming from BIOS that is, you know, is universally supported everywhere, and that's because of this emulated VGA text mode that happens. But then, you know, beyond that, once you boot into an operating system, like you'll see this in like the Windows installer and a lot of Linux distros and a lot of special purpose operating systems, even without any kind of graphics driver for your specific card, they'll understand how to talk to your graphics card. And that's purely because of this, you know, ancient Visa BIOS standard where you have this driver that runs in this, you know, very limited BIOS environment, you know, written in the ROM on your video card. And so, you know, that's designed to run in DOS, but then there's a 32-bit version of it that not a lot of people use or support, but it exists, and some people use it. And then you can run that in protected mode. But then other people just take that 16-bit driver that exists in your Visa BIOS, and they run that in some kind of emulator after the operating system is booted. And so I don't know if modern versions of the operating systems have reason to do this still. I think it might finally be on its way out, but at least, you know, as of when I was working on this, which was like early 2000s, no, later than that, like 2005 through 2010 or so, like at that time, it was still pretty common for operating systems like, both Windows and, Linux via X11 had ways of just taking that old code and running it in an emulator if there wasn't any other available driver. And because of that, if the emulator did something weird in between your driver and the hardware, then you kind of had to be responsible for that. So there was this weird thing that the virtual PCI device would do where, because it was in control of the bus cycles, it knew that there was a difference between writing a 32-bit word to address 0 and writing a 32-bit word to address 1. And it could, even though that write to address 1 on some other architectures with a sane memory policy like ARM would see that as an unaligned write and just disallow it. On x86, it's like, oh, cool, that's fine. And it's just up to the hardware what happens. And if that was memory, then it would be an unaligned write, and it would get broadcast to, as bytes to address, 2, 3, 4, 5, or 1, 2, 3, 4, or whatever. But if it was a piece of hardware, then, it's just a bus cycle that shows up at that hardware for it to do whatever it wants. So the virtual hardware it had all these 32-bit registers that were laid out at addresses that were not offset by 32 bits, just assuming that, that was fine. And on any real hardware, or if you were running that driver directly in the virtual machine, it was fine. But I think some version of Windows decided that when it picks up that driver and then later uses it inside its own little x86 emulator, then it's going to break up that unaligned write into a bunch of bytes, which is this thing, like, it's a pretty sane thing to do. Like, a lot of emulators might do that, especially if they're running on, like, ARM, where that unaligned access would end in a seg fault. And then because of that, we ended up with this terrible workaround where there's like a state machine in there that keeps track of byte writes and kind of reassembles them into words. And so you get different behavior depending on what order you write those bytes in. So... And that's just the tip of the iceberg. Like, virtualization and just computers in general are just made of that stuff. I don't know why I like it. Because, like, so much of it is so bureaucratic, but I think what I like is there's a really big knife for cutting through the bureaucracy. Like, I think I really appreciate that part of it. So that's interesting. I need to keep track of how much space I have vertically, because I just soldered in all these transistors, but now I'm noticing that I should check this against the length of the spacers, because I might have these too high, which would be sad, but I think there might be enough space. Yeah, there's enough space. Okay, so that's how much space I've got. So I think this is the goal. I think the transistors want to be on the inside so that they're kind of protected. And then the resistors show up around here. And then I think you want the LEDs pointing outward. Or maybe they... Yeah. That seems right. I know there are pictures I could look at for how this is supposed to be assembled, but I feel like that's cheating all of a sudden. Oh, this is labeled with plus and minus on this side, which I didn't see before. But yeah, that matches the reverse engineering. So there's our common rail here shared by the emitters on all of these transistors. And so oh, that's interesting. Well, maybe I do have something wrong here, because I was assuming that I want these like wired kind of crossways, because if this was just stacked one on top of the other, then I don't think the resistors would do any good. You wouldn't get them, these wouldn't act as pull-ups. So I think you want these to be mirrored, and that would mean that, like, I think that's how you get all 6 IOs on this connector properly. But then if you mirror it like that, then I think that means that the plus and minus aren't right. is there. Yeah, so if you flip it, then plus is on the left. So, oh, is that what? Yeah, maybe this is part of the puzzle. And I still haven't figured out what these other two holes, that one and that one, are for. Like, I don't know if those are wires or resistors. Oh, and one of them is square and one of them is circle, if I'm right. Oh, yeah. So what do we know about the square versus the circle holes? Oh yeah, and there's also a capacitor. There's a capacitor, and how much wire is there? I mean, I know that there needs to be wire, like, I guess I've decided that these 6 pins over here, those are all gonna need wire. And there might be wire involved on this side. I don't know about that. And then those are just LEDs. And so the LEDs definitely have like a pin 1. So in this case, we've got a square for, I guess, the positive, the anode, and then a circular hole. So pin 2 would be the cathode going through the transistor to ground. But then over here, like these are both different. Like all the resistor pads over here are this kind of rounded square shape. But over here we have distinctly different pads. Well, let's go to the microscope where that's clearer. And as far as connectors, we have one power connector and one data connector. Both of them are these surface mount style headers. So I'm assuming that we're just going to pick one of these boards kind of arbitrarily to have the connectors on it, and then the signal gets passed through to the other board. So I might as well go ahead and solder the connectors on just to have one fewer thing to lose. And then that'll differentiate these boards. We'll have one with connectors and one without. Oh, there's another comment about virtual PCI having a lot of ability to kind of duct tape different components together. And yeah, that was part of the appeal of virtualization for me, for sure, is that it's this giant Swiss Army knife that you can use to just color outside the lines in every possible way with computers. You know, you can have hardware pretending to be different hardware, and you can have programs completely lose their notion of time and have their storage redirected, and you can save their instruction streams and you know, fork their execution without them knowing, and just do so many interesting things. I'm not happy with this DSLR angle. Not to mention the focus. There we go. That's better. Now I'm going to do the thing where I solder one. Oh, I thought I was going to have to be really careful about positioning these, but I think it actually is smart enough to lay flat. Oh, that's great. Yeah, the the height of the spacer and everything is such that it doesn't just want to tip over, it actually will sit there while you solder it, which is great. I guess I've had some bad experiences with these in the past. You'd think that that would be common for them to be able to just sit there. So I will have to kind of tweak the position with this first one. Okay, that's as straight as I feel like. I don't want to melt the connector. I feel like I'm already taking a risk there. Oh, speaking of melting, I think I'm getting my vice draws a little bit. Ah, that's a very satisfying flow. Oops, less satisfying that time. I probably shouldn't have moved that, otherwise it would have been a nice continuous shot, but maybe that doesn't matter. Cool. Let's do the other side. One connector, two connectors, power input. Not a cat hair. That cat hair can go elsewhere. So I guess on one of these, the text will be kind of covered up by the connector, and on the other one it won't be. So maybe that influences which one goes on top. Yeah. Are there any other Boldport Club members in the chat tonight? I know there's also a chat for the Boldport Club, which I've had my client open for it, but I haven't actually been like really present in there. Hasn't quite gotten through my social anxiety threshold. I'm especially interested in getting to some of the other surface mount kits later on because, I mean, partly because I like surface mount soldering, and partly because I might be able to use some of the footage for some of the other videos I'm working on, so there might be some more overlap I can exploit. Because I like overlap. I like it when projects can connect together. It saves work, but it also helps things tie into each other when they might otherwise be more lonely. Oh yeah, there's another another point about VGA in the chat from K Temkin that doesn't like modes that aren't a multiple of 8. And oh man, there are so many little alignment quirks. Like, I think a lot of adapters, like the one that we had at VMware included, would just round the width up to a convenient multiple so that it wouldn't have to worry about multiples that weren't aligned properly. So, you know, we could often sidestep that problem with the screen as a whole, but then you would end up with versions of that problem showing up for individual bits of graphics memory, so textures or like off-screen bitmaps of various kinds. And so, or even stuff like cursors. Cursors are terrible. They're just loaded with special cases for this tiny thing. And so, yeah, some of the early bugs I remember doing reverse engineering for would be like, oh, we'd run Half-Life 2 and it crashes somewhere related to the graphics initialization, and it's probably vaguely our graphics driver's fault, but it's crashing in code that isn't ours. So that happened a lot, and one of those led to something that turned out to be like memory alignment related, where, I don't even know if this was actually part of the API that we weren't implementing, or whether it was just something they were assuming, but they assumed that this particular kind of memory that they were mapping would always be like 16-byte aligned or something, and then so they would use like 3D now instructions, I think, on it, and that would crash, like segfault the application if the data wasn't aligned, because that's just how those instructions work. That's how the CPU complains. It doesn't have just a slow fallback, it will just crash. So, I think we're out of connector land for now. Let's go back to the SLR. Ooh, good question. Someone's asking in the chat. George is asking about IRC channels. I don't know of any myself because it's been a while. I used to hang out on a few channels in Freenode ages ago, but it's been a while since I've just idled on IRC. I think lately it's been helpful to kind of packetize my interactions a bit more, and I like Twitter in a lot of ways, but it'd also be nice to have an alternative to Twitter that I like in some of the same ways, but that isn't as kind of centralized and kind of problematic from a control point of view as Twitter. It'd be nice to have something that is more openly deployable. So what do we have left? We've got a bunch of resistors. We have 6 of each kind. So I'm guessing that the 6 resistors, so we've got 6 on this side, 1, 2, 3, 4, 5, 6, and then these pads. So if you ignore these, which are wires, these, which are mystery for now, then there's 6 spots for resistors over here, 6 spots for resistors on that side, and we've also already determined that some of these resistors are basically I/O pull-ups for the gates on the transistors, and some of these are current limiting for the LEDs. So I will check the values more closely later, but some of these are like 10K and some of them are like 150 ohms. So the small ones will be for the LED current limiting. So the resistors should be pretty easy, but I'm not going to put them in quite yet because that'll be like one of the last things we do to like assemble the Cordwood stack. First I want to figure out what the capacitor and these pads and like the power in general, like what's all that about. Because it looks like, based on how the resistors are, these have to be swapped. So there has to be something mirroring this. And the transistors could be facing inward like that. They also could be facing outward, I don't know. I mean, if they're facing outward, then the LEDs facing outward maybe make more sense, even though the whole thing is a little bit more exposed. But then more of the artwork in here is visible. So maybe that's nice. Maybe that's how I do it. Because there is all of this writing like on the edge here that is meant to be seen for sure. And the transistors were definitely meant to go on this side. So let's assume the transistors are maybe supposed to stick out. And then the LEDs also stick out on each of these sides. And then, we need focus. We also need less wobble. I need something that's like a sandbag that I can put on the Manfrotto magic arm thing that just like damps the vibrations. So on here, I think we really want that to be roughly like that. So the sandwich with wires and resistors, and then each half of that connector goes to a different board. But then if all of that is correct, then we have to find some way for the power to work out on this side. So it looks like, so that's plus, that's minus. So I guess one of those could be a capacitor if it goes, ooh, sorry about the focus. If it goes across, like kind of at an angle between like that pad and that pad, that would be a good place for a decoupling capacitor if we wanted one. Something like that could go on either side. It's just that at some point, like if I want the power to be connected together, what is that noise? Oh, that's weird. I just heard like a weird like scraping noise coming. Oh, it just, I guess you can hear that too. It's a screw rolling around on this glass surface. Okay, let's not have that. Let's put the screws slightly in the standoffs so they don't roll around. It's just catching up on chat a little bit while I put these resistor ends. It's nice to see people joining from all over. Hello to the UK. Oh yeah, there we go. I'll get at least a little bit of this in focus so I can use the footage later. In fact, maybe I can even get that a little closer. Yeah. Yeah, nice little fasteners. My favorite fasteners have got to still be like stainless steel M3 button head machine screws with oh yeah, I'll have to get some of those out. Those are pretty great. I mean, not right now, because like I'm not going to do that and make these look bad, but you know, I do have a soft spot for some fasteners. I mean, Tuco's got his favorite bolts. I've got my favorite bolts. You know, we get along that way. All right, so power. Now that I've diagnosed the strange noise that was about to drive me more crazy than usual. So, oh, Tuco, you look so comfy. Maybe I can get a better angle on him now. There we go. Kitty cam. Aw. All right. Oh, that's another good question from the chat. A project that's more about making something rather than reverse engineering. And that's a good question. I mean, I've got some stuff planned for sure that's like kind of making stuff in service of reverse engineering, if that counts. But yeah, I think like just making stuff for, you know, like for Tuco or making stuff for like art projects is totally within the scope of the channel. It's just less what I've been working on day to day lately. I've been a little bit less kind of enthusiastic about the art projects just in the last year or so after working way too hard on one particular project, but I'm sure the pendulum will swing back around and I can already feel some stuff coming up that might be interesting to stream about. Just noticing the detail on these traces going under those little silkscreen shapes. I really like that. Just trying to get that contrasting on the light a little. It's like this one's a little impulse or something, and this one's like a little zigzag or an N or a Z or something. Okay, so we've got these two little square paths. And I mean, maybe one of those is a good spot for a capacitor. I should see how close to the standoff those come, because I don't know if that would be a spot for the capacitor if it doesn't have as much clearance as it really wants. I'm doing a bad job at manual focus, so I'm going to put the robot back in charge. Hello. Oh, maybe I can do a better job. Yeah, see, I'm guessing that maybe those pads are just intended to be an alternate footprint for that connector, because they look really close to that standoff. But, I mean, it's the same way on that side, so they could be wires. Like, I could imagine wires there, but maybe not a component. So I'm guessing that maybe a wire goes there, and then another wire goes here, and then a capacitor goes here, and that's how it's connected. But let's see how that would have to look. So let's just put this on for slight convenience on having to carry fewer things in front of the camera. Okay, so it would look roughly like that. And let's assume, so we've got, let's say minus on this side, if we want it to connect to minus on that side. So minus on the bottom side is farthest from us. So we could just have a kind of a diagonal wire going near the standoff here, and that would be fine. And then minus to plus down here for a capacitor could be relatively straight up and down. But like the problem is we still want to connect, like we need two crossway connections here. And like the standoffs aren't electrically connected at all. And I don't think it's intended to need separate power for each side. I think the two sides are supposed to be connected. So, plus on that side. I guess there is room. Huh. Yeah, maybe this is just intended to be two wires crossing, because that looks like it could fit there just fine. And then maybe there is room for a capacitor here. Or maybe the capacitor goes, I don't know where else the capacitor could go. So I'm thinking like that wired to there, this wired to there, and then the capacitor could go in either of those two holes. So let's see if that fits. I mean, this doesn't really need the capacitor, but I could imagine it maybe being useful if you were trying to do like high-speed LED pulse width modulation. Oh, what is this? Oh, this is the sticker. That's important. Okay. So this would go in either of those holes. Huh. You know, that looks like perhaps it was designed to be just barely large enough, or just barely not too large. So I think we figured it out. I think a capacitor straight up and down so that it goes between plus and minus, and then two wires crossing to distribute power. That makes sense. I mean, you could also do the capacitor non-Cordwood style, but that would be silly. This is totally the way this is supposed to go. So I think we can start threading some components into this now. I think we figured it out. So let's take a look at these resistors. And T. T is important. T and cats. All right. So these resistors, these beautiful resistors, which are these 1 watt? Really nice looking. So I think that code is 151, so I think that's 150 ohms, but we'll double check with the meter. And then this one here is brown, black, orange. I think that's orange. So I think that's 10K, but let's check that out too. Or it might be 100K actually, I think. Let's give the meter a shot, because I can't quite tell whether that's supposed to be red or orange. 100K would be yellow. Orange would be 10K. Great, so these are our pull-up resistors, the blue ones, and then our nice LED current limiting resistors are 150-ish. Don't worry too much about the, well, I will actually cut these out of the strip. I don't like this glue stuff, and so sometimes I cut it to avoid the glue, but in this case I'm also going to cut it to avoid bending the leads, because I like how unbent they are right now, and that would be nice to preserve. Okay, so now the side that we're interested in is so this bottom side here is the one that has, let's get a close-up on this identifying feature. So with our capacitor in place, yeah, so this is where our resistors will hang out. Actually, I think what I want is, yeah, I think these go on this side actually. This, oops, there we go. So this pin goes into the gate of that transistor, and it's easy to tell that that's the gate because it's, oh, can we get any closer? Maybe the microscope. Oh yeah, that's better. Let me switch the video. So this one, this is going, oh no, okay, I had this right the first time. Sorry, I was thinking about the pull-up resistor, but this is totally the hole where the one I'm holding, which is the current limiting resistor, goes. So the other hole, the one I'm not putting this into, is the, which is also not in focus. Okay, that hole that's empty is where I'm going to need the 10K pull-up, because that's also the logic input. You can tell it goes to both the gate of the transistor and over to this input header. So I'm leaving that one free, but then the other side is, on this board, a power rail So this just goes over to the connector. But on the other board, I think that will turn into our LED connection. So let's just verify how that hooks up. Oh no, maybe I am getting this wrong. Because this first one here is a oh, let's focus that. This first one's a logic pull-up, and then this next one here goes to an LED, and then logic pull-up. So I guess they're alternating on each side. That would make more sense. Yeah, because all of these get pulled up to the same rail. So, okay, that makes much more sense. I feel like I need to rotate my mental map 90 degrees. So, let's get these in order. Maybe the resistors, and then the capacitors, and then the wires are the easiest assembly order for this. The resistors are definitely the fiddliest. Oh, such cat. Oh man, such a good cat. Okay, so with this on top, so anything going into an LED directly is going to get this low value resistor. So that, or I think this one, let's double check. Looks like it. Yeah. And then that one. Alright, cool. So there's our current limiters for this side. Kinda wanna find some way to hold these in so they don't fall out. Like maybe just put a little flag of Kapton tape on the end. Oh, there's a question. Oh no, there's spoilers in the chat. I mean, I was already pretty sure that the green side goes outwards, but yeah, I think you're right. Yeah, I mean, a circuit diagram, I guess drawing one out, I always wonder like, oh, is it worth the time to just like sit there? Because I always feel like such a doofus when I'm like, oh, should this wire go here? Or should this wire go here? And so, is that better, or is it better just to find out where you're wrong on the fly? I don't know. I think it depends on the kind of content I'm making, but it might also just depend on the mood I'm in or what the circuit is. I imagine, okay, now that I'm doing this, I have to imagine there were some interesting jigs that people developed for getting kind of Cordwood style circuits built. Like something you could put all the boards in, or all the components in, and it would kind of line them all up, or like give you at least like a place to put them while you brought the boards in. But I mean, I can't imagine that they would put a lot of time into developing something like that, but at least like, you know, an interestingly shaped piece of wood or something, I can imagine. Nowadays you could use a 3D printed jig of some sort. Alright, let's put some more resistors in. Let's cut these out. Let's restart this. I think I've got a friend coming over around 8 o'clock here, which is in like 45 minutes, but I think we'll be done by then. And if not, maybe he wants to join the stream. It would be interesting to do some stream collaborations. I'm such a hermit, like I don't really know a lot of people locally, but I have a couple of friends. I have one friend around here who streams like video games. I think she mostly has been streaming Overwatch lately, which I don't know much about, but she likes. The resistor rolls away. Alright, this is coming together. So then 3 more 10K resistors on this side of the board. And put some more tape on there to keep them from completely disconnecting themselves from this situation that I'm building. Kapton tape is pretty great. Oh, and Tuco is slightly out of frame. This tripod I have Tuco Cam on is the worst tripod. There we go. He's in the dark, but... Oh, there is a lamp over here I guess I could turn on. Kitty. Oh yeah, there's another question in the chat about if it might be interesting to kind of have a live stream that's also kind of making actual products. And yeah, I mean, I think that's definitely a viable thing, and I think that's something more people are starting to do. Like Limor or Lady Ada does that a lot, actually. Like, she has a pretty regular stream where she works on stuff that's actually like upcoming products for Adafruit. And yeah, so I have inspiration. I mean, she's a big inspiration to a lot of people, myself included. I think her streams are really great, both for showing the behind-the-scenes process that she has, but also just for kind of encouraging more people to stream similar stuff. How was your nap, Tuco the cat? These little bits of Kapton are way too long. I feel like sometimes I need a machine or like some kind of doodad that I can just tear off tiny pieces of Kapton tape from. Like pieces that are maybe a centimeter long. Would be nice. Okay, so that's all of them on this side. Cordwood. Let's put that wire in while we're at it, I guess. Yeah, let's finish the resistors before we get onto wire. I'm a little too ADD for one topic, but let's see if we can manage. So let's figure out which resistors go where on this particular side. Microscope. Alright, so similar story. There's our capacitor, bunch of resistors in the background. And so on here, actually, we can't really tell because this is all our positive rail. So let's populate the resistors on the correspondingly meshing side of the other board, since that's where we can actually tell which one goes where. Yeah, So here we have another alternating thing with, there's the 10K resistor pull-up, and then the LED current limiting resistor, 150 ohms, and then 10K, 150, and so on. And I guess let's put these resistors in the other direction with, yeah, actually, let's make them consistent and have the gold stripe toward VCC on both sides. So, yeah, nice. Let's do that. 10K. So shiny. That through plating is so nice. I do want to try those. A couple of people have suggested these rivets that you can use to kind of plate your vias when you do your own boards. But man, the chemical plating on a typical manufactured PCB is so nice. It would be interesting to try to do that at home, although I don't really like having to dispose of chemical waste. Yeah, I think there's probably a lot of room for both kind of really densely produced video and kind of more ambient streams. But I'm still not really quite sure where the boundaries are between, like what is the job for each of those. And I don't know whether it's going to come down to learning style or like what kind of, like whether people want to like pay a lot of attention for a little bit of time or kind of sort of pay attention for a long time. And I think personally, I appreciate having both of those, and I mean, maybe it just comes down to different subject matter, or maybe it just comes down to kind of, I just try to do both, and people watch whatever they're interested in. But yeah, I think Adafruit's another good model, because they do both a lot. Like, they do like film shoots for video that has really high production value, and they also just do off-the-cuff kind of streams that show exactly whatever they're working on that night. And I like that a lot. Sometimes I catch myself watching the wrong monitor. Where by wrong, I mean, like, I've got this monitor that you can just kind of barely see, this one right here, and that's what shows the microscope most of the time. And I put it on the desk like that because a lot of the time I want to get it in the DSLR shot, because, I don't know, I think it kind of helps tie the thing together. Like, you're not only seeing it with a picture-in-picture overlay, you're also seeing that I'm seeing it and you're seeing it. And then you can also see that when it cuts to the full screen overlay, it's like exactly the same video, so it gives you a sense of coherence. So I like that. But I also often catch myself, well, so I look at these other two monitors I've set up, one with the computer, well, the same one that we were seeing data sheets on before, and then, which is still recording and using up hard disk space, but that's okay, disks are cheap. And then there's another monitor I keep checking because that's what actually has the stream on it. And so if I have the microscope on the stream, it's actually still pretty usable, but there's just enough lag that it kind of starts to get into that uncanny valley of perception where it kind of works, but wait, why am I so bad at moving things? I wasn't so bad before at keeping objects positioned. But yeah, it really is amazing how much just a little bit of lag can mess with your perception. It's definitely another thing you run into in like graphics and graphical interfaces and video drivers and all that. Because like working on virtual graphics devices, like you're on the fast path for every user interface interaction, and there are a lot of opportunities to get it wrong and very few ways to make sure that you don't ever stall things when the user is watching. So, I mean, and lately, operating systems have gotten a lot better at that, but mostly via brute force and just having extra buffers for everything. Oh, there we go. I was missing one resistor and it was hiding. There's the last one. And I think having different content available for people with different learning styles is hugely important, I think. Because, I mean, I got some out of the classes I took and the textbooks that I read at the time, but like the vast majority of what I know is stuff that I taught myself and in a lot of cases learned before I even like went into any kind of organized program for learning it. And I think what helped me was just having a lot of stuff to experiment with and the occasional like mentor to look up to. Like I really liked the Forrest M. Mims books when I was a kid, and I still, you know, he's one of those like electronics mentor people that really stands out, and I think he's helped a lot of people discover a love of something that they can get into like this. These little flag things sticking out. Alright, so all the resistors are in, the capacitor's in. I think all that's left is the wire, and then actually putting the two pieces together. Oh, and the LEDs, of course. You know, I probably want to put the LEDs on much sooner than later, because the LEDs, you know, I want them to sit pretty flat, and so I probably want to be able to put this in the vise. So actually I probably should have done that even before putting the resistors on, but this will be fine. I might use a different vise though, something that gives this a little bit of room. There's my little vise. Little vise. Little vise. Huh. Oh, there it is. Little vise. Little vise. I mean, I say little, but it's so much bigger than these other vices I've been using. I also have one of the larger Pana vices. Let's also make sure I'm not losing this screw, because that would be great not to lose this screw. So, LEDs, how do we want those to go? Let's first just make sure that the polarity is where we expect it to be. So, let's do a quick diode test. So it looks like that's positive. Okay, it's barely showing up on camera, but it's lighting slightly and getting a diode test reading of 1.8 volts. So, yeah, the long lead and the lead, or the long lead is the anode, as you'd expect, and the lead with the little cup holding the LED die is the cathode. Alright, so then on here, looks like our long anode lead is going to go to the left where it hits one of these current limiting resistors, and then the cathode goes through a transistor, whoops, And yeah, so the lead to the left is our anode with the shorter leg, with a shorter lead frame inside and the longer leg. Yeah. That goes to the resistor, and the other side's going to this transistor switch. So, mechanically, how do we want this to sit? There's a little, there's like a little catch in the lead frame where it's slightly wider, so it looks like it kind of wants to sit right there. It seems okay. I mean, it could be taller, though. That might be nicer. It'll also sit all the way down, which is kind of nice looking. Let's get another angle to check that out. No, I think we want some leads. I think that's sitting... Oh, the camera is much closer than I thought it was. All right. Yeah, so it's going to have a couple of these, and so I can choose the order and how I mechanically position them. I've got red, yellow, and green. Does red go in the middle, maybe? It's like the most, like, bold kind of, I'm here, I'm a color, look at me. I kind of like yellow on the left. I feel like people are probably going to want this to be a traffic light. But it'd also be nice for it not to be a traffic light. There's something really satisfying about those resistor or those LEDs just sitting on the board like that. I mean, it does obscure the traces a little bit, but it also makes it kind of stronger. So oh, there's a question in chat about whether I'm in Florida because they heard the train outside. I'm in California, but there's definitely a train like right outside my place. It's goes up and down the coast, moving people and oil. Oh, that's pretty nice. You can see the lead frames in the LEDs kind of nicely. Okay, yeah, I think I'm just going to do that. That seems like it'll be the sturdiest. Like it won't have LEDs kind of sticking out, ready to break off, and the LEDs will actually protect the transistors a little bit. So let's do that. In that case, I don't really need the vise. I'm just going to bend the leads so that they, or maybe I'll actually just even use some like putty, this, what do you call this? Blue tack, I guess I've heard people call it. Because if I just put some of this on my work surface and stick the LEDs down, then I think I can get them flat. Let's try that. Yeah. Yeah, I like that order. I don't know why, but it's nice. So, I can just gently bend those leads out while putting a little pressure on it. resistors come flying down. That's not what I wanted to happen. One of my resistors came out, but I'll put it back in. Don't worry, it's not the end of the world. Other things might be, but this totally isn't. Okay. Definitely would have been easier to do with the LEDs fully installed before even attempting the resistors. Okay. Can I get any of that under the scope? Kinda. Okay. It's a bit of a jungle in here, but we'll just add some solder and stabilize it a bit. Let's restart this camera. I really like these old LEDs. They definitely bring back a sense of nostalgia. I'm going to touch up these LEDs, or touch up these joints after clipping the leads, but right now I'm mostly interested in stability. Oops. I still have some of these LEDs somewhere that I feel like there's got to be something to do with them because they're just so old, but maybe it's just wishful thinking at this point. They're labeled General Electric solid state lamp, and they look roughly like a 5mm LED, but the molding's a little different. Like, they don't have the long and short leads or the little ridge on the can. One lead is like brassy looking and the other lead is more tin looking. They're really inefficient. Like, they're dim, and you kind of have to drive them at like 20 milliamps, and they put out hardly any light. But I remember getting some of those in a like surplus bin from this electronics place I used to frequent in Denver. Alright, I'm going to go back over these to get a good finish and a better mechanical joint. Yeah, I'm still getting a dull finish. I'm not quite sure why, but maybe something about this solder. Alright, I'm going to check my phone. I heard it buzz and I want to see if maybe my friend is trying to make plans. Oh. Ah, that was my neighbor texting to let me know I had a package in the mailroom. So nice of her. They're good neighbors here. It's like a weird little warehousey building. Kind of attracts weird people. But like weird in a much more responsible way than the weird people I had last time. Like weird adults rather than like weird 20-year-olds. Much better for housing at least. And best of all, it's like separate units. I'm not like sharing common space and all that. Oh, do these go the same way or do I make them different? So they're gonna face inward. I think I want them to be symmetric. I could make them like anti-symmetric, but I think I want them to be symmetric on this one, just because I think that would be nice. So let's have this one be green. Cool. So we should still be seeing negative going toward the long connector. So each of these negative leads connects to a transistor, and the positive connects to a resistor. I was always much more into looking at the shapes inside the LEDs when I could than relying on the leg length. But I've had LEDs occasionally where it's kind of backwards than you expect, where like the little cup that holds the dye is actually the anode, which is weird. But sometimes it happens. I don't know why they would do that, like what the manufacturing reasons would be. My first impression is that maybe it's related to the technology that they would want to use for making like common anode displays. Like maybe there's a different mounting, and so if you have dice that are optimized for that, then maybe you mount them with the lead frame positive. This is stuck on a resistor. There we go. Like at-home LED manufacture would be interesting. Like doing the like epoxy encapsulation and putting the dice, bonding the dice onto a frame. Like even if you don't make the dice yourself, that would be an interesting process. Yeah, that's nice. Oh, I still have some kind of harrowing memories from soldering lots and lots of through-hole LEDs on this one project. I don't know, some of you might be familiar with an old Evil Mad Science Labs project, the PEGI board. So I got one of the PEGI 2 LEs, which was a matrix of, I think it was like 30, maybe it was less than that, maybe it was like 26 on the side, but it was a square matrix of 5mm LEDs. And I got the board, and I got, well actually I already had a lot of LEDs kind of left over from a different project that didn't quite pan out. And that's part of why I got the PEGI, is I wanted to make something with them. I had this other project that was going to be like a high dynamic range active backlight LCD screen, but it was a big complicated project and I didn't really adequately scope it out, and so it kind of petered out. But it left me with some odds and ends, including a bunch of white LEDs. I think like 1,000 of them. And at the time, I thought it was a really good deal to get 1,000 5mm white LEDs for like $300 or something like that. Then a bunch of time passes, and they're not great LEDs anymore, but they're still all right. And so I decided to get this PEGI kit and turn it into kind of an arbitrary pixel display. And so it was great. It's just a lot of soldering, as I'm sure you can imagine, for probably, I think it was somewhere in the neighborhood of like 600 LEDs, but I don't remember off the top of my head. I used a lot of that kit of 1,000 for other things. But my technique at the time, I wanted to get the LEDs set like very flush against the board. So part of how I was trying to do that was to use gravity to help line them up, and then like basically super glue them down after like gravity settling them, and then flip the whole contraption. And it worked all right, except for the fact that I was then like applying all this heat to this board that was covered with mostly but not entirely dry superglue residue, which then heats up and starts emitting all these fumes. So it was gross. I had to ventilate the room very well and would not do that again. And I assume the way to do that for reals is to have some kind of jig that lines them up. Like, I don't know how else you would do that manufacturing-wise. I mean, either you just have a robot do it, which is, I guess, how I would assume they're all done now, for the most part, or you have jigs that help you like line everything up just right. Oh no, my soldering iron decided that I was done and went to sleep. Let's turn it back on. Oh, is the feed all right? Haven't been keeping an eye on the OBS health and all that, but it looks like we're at 30 frames a second now. Let's see what YouTube says. YouTube is saying my video output is slow. So I don't know whether that's a network problem or a video encoding problem, but we'll see if it goes away. I expect it's a video encoding problem, but actually, as I'm saying that, I'm now realizing that I might have BitTorrent open on another machine, so that might be a problem with the stream that I could solve. Oops, bad angle. Alright, so that's the LEDs. We're about ready to join the board. I'm going to take this opportunity to get up and try to kill any bandwidth hogs that I might have. Okay, let's see if that's any better. I think maybe slightly less of my upstream is going to be taken now. Alright, so we got our LEDs all looking nice. Okay, I'm glad I put those flush against the board, because that looks and feels much nicer than if they were wobbly. Alright, now the only component left is the wire. So I'm going to do the power wires first, and then like add the tape to those maybe, but then the The signal wires, there are just so many of them that I'm not going to worry about the tape. I'm just going to put those in like last. I mean, the crossy wires are going to be harder, but the straight wires I could even put in after doing everything else because they should be pretty straightforward. Haha, straightforward. I'm going to start out by cutting two, well, yeah, actually maybe the wires are easier after just assembling these two pieces. I think that's the case. I think even the diagonal ones, the wires are easier to put in after. Such a cat. Alright. And let's put these standoffs together. Let's not have the microscope so big right now. Oh, stopped automatically for your protection. Oh, there's a question in chat about electronics in Denver. So it's been a long time. I don't know if they're still around. The place that I have very fond memories of going to as a kid is called Gateway Electronics in Denver. I don't remember where they are because I really don't have any concept of Denver geography anymore. But they were a pretty cool surplus shop that had, you know, you could walk up to the counter and ask the old dudes for some chips, and they would give you some chips. And they had kind of a good mix of like electronics, jelly beans, but also like weird industrial odds and ends. I've seen some places around here that are more of the latter, like there's Halted Supply in Sunnyvale and Weird Stuff, and they have just all this great like industrial waste basically, but then, you know, for like electronics parts you'd go somewhere else like Jameco or order them online. Alright, so these are gonna go together, believe it or not. If I can actually get this on camera. Thank goodness I'm servo AF right now. I'm just trying to find, it sort of reminds me of doing something with like tents or something, like trying to find out which pole is longest and then maneuver it into place. It also strikes me that it would be really easy to put this capacitor in so that it's like between positive and positive or negative and negative, and it would be really easy to not notice. Oh, why is this movie recording stopping? I think this card might be getting full. Let me swap it just in case. Camera just like beeped at me angrily. I'm hoping that doesn't mean it lost anything. Another 64 gigs down the drain. Oh man, Tuco, you're so photogenic. Oh, the camera keeps stopping, mostly because it's a Canon DSLR, and it does this thing where it only records for 30 minutes at a time. Which I think was originally some like export restriction thing or something. There are various workarounds. Like I used to use Magic Lantern to work around it, but then that caused another problem that I didn't have a good workaround for, where it would just corrupt my card sometimes. But if I can get it recording using something external, that would be nice. And then of course, like one of these days I might just get like an actual video camera. can kind of control these remotely from the other end like a foosball table. Like pull this resistor, and then maneuver it, and then push it into the hole. There must have been some jig to help these satellite builders of yesteryear build these things without maddening levels of retrograde action every time they try to put something in, having like 4 other things fall out. Is that all in? So I've got resistors on the side. Resistors on that side. I think that's everything except the wires. Let's put the screws in. Oh, hey Tuco, you're standing up. How was your nap, little guy? Adorable little tiger. Oh. Man, even holding this thing is kind of challenging. Let's try... moving this again. Yeah, something like that. Maybe even having a screwdriver would help. Oh, there's a comment that maybe some people were just more careful back then because there's a lot of wire wrap and like kind of peg assembly and stuff like that. And I mean, I think being careful was part of it, and like people were maybe in some ways more apt to have this like really detail-oriented work. But then like manufacturing is still very detail-oriented, so I don't think that has necessarily changed super much. But I guess I can't help but imagine they had like jigs that they put stuff in to kind of line everything up just right, and then kind of would help hold parts into place before they were all soldered when they made stuff like this. Because part of making something reliably is being careful, but then part of it is just going to be good process, and I think I would expect somebody like NASA would be doing a lot of each. They would have very careful engineers building this stuff, but they would also probably have equipment that they built themselves to make it as reliable as possible to put it all together. Oops. This screwdriver is too small. Okay. It's not screwed completely down, but it's mostly together. I'm going to get a better size screwdriver to tighten that down. Oh yeah, just got this new set of tiny screwdrivers. Whoa, that's cool. A comment from Sodium in chat. Just found a NASA document entitled "A Fast and Economical Technique for Welded Cordwood Electronic Module Fabrication." That sounds cool. Welded cordwood. So I wonder if welded actually means something like spot welding, or if they're using that to refer to soldering as well. I would assume that would mean like actual spot welding. Yeah, let's use this. Flip it over. Yeah, I should flip it over. Good call. Let's flip it over. Oh yeah, it's totally flipped. Look at that. I'm going to tighten these, and then I want to put the wires in, just have all the components down, and then it's just keeping things kind of positioned and soldered. I really like circuit board standoffs. They make me so happy, like having boards fit together into a module. Like that's how you know you've made it. It's not like having a plastic enclosure or having your thing like in people's hands. It's having standoffs on your circuit board. That's totally going pro. All right, let's have some wire. So let's double check this capacitor. So the capacitor is going in at this angle. So it should be between plus and minus on account of being stuck in there diagonally. Oh, actually, no, that's wrong. I did that wrong. The diagonal connects same to same because that cancels out the 180-degree flip. So this is in incorrectly. The wires need to cross, but the capacitor just goes straight across. So I think I can do this by bending it and then bending it back without damaging it, because I don't want to have to do all the resistors over again. Cool, and the bendy looking lead is not even the one that I was mangling. Let's get them both straightened. Okay, that's going to be a more effective capacitor. I was just talking about how easy it would be to make that mistake. Like, oh, some doofus who wasn't paying attention, like me, could just totally have that capacitor soldered between ground and ground. But now it's safely between plus and minus. Luckily not polarized, because that would be yet another thing to get wrong. Okay, now some actual wires. Are these long enough? I don't think they're long enough. These are the LED leads. They're a little bit too short. This is the wire that it came with. Oh, there's a question. I just noticed something in chat. There's a brown resistor that came out of its hole. Let's take a look. Oh, yep, that's totally right. Good eye. Thanks, chat. Oh, I think I'm going to bend that back into place, too. These seem to be fairly pliable if I don't expect too much out of them. Pliers. Okay. That seems about as straight as all the others. Great, thank you. Yes, thank you, Jarrett. That was a good observation. Let's add some wires, like I keep saying I will. So, crossed this time, not like the capacitor. but going from minus on this side across to minus on this side. Actually, I really like the idea of combining these like long streams for Boldport with the short music video kind of things, because I like that presentation style, especially for, you know, for something like this where I think there'd be a lot of aesthetic detail to appreciate, but the actual narrative itself doesn't have a lot of separate steps. So I'd probably want the video itself to come together pretty quickly, but you know, this way I can, you know, I don't have to kind of have quite so much of a dragging on like video. I get to produce something that's very fast-paced to play back, but then if you want the longer experience, you can join the stream in real time or watch the stream archive. Hey, Tuco. You are so in the way now. Hey, little cat. So because of this wire being kind of harder to, well, I mean, I could put tape on the wire just like I'm doing with the components, but I think at this point it's easier just to solder one side and then clip the other. So I'm just going to go ahead and get to doing that. Let's solder the first wire and then put in 7 more. And yeah, maybe I want some angles so I can see that. There we go. Let's get that on the screen. There we go. Microscope. Nice thick chunky wire. Hey, Tuco. So if you're just joining us, this is a kit from the Boldport Electronics Club. It's the Cordwood puzzle, kit number 3. I'm just going to solder one side so that I can straighten out the wire and have room to adjust the tension a little bit. So let's see if I can get that on the scope. Yeah, so on that side, that side's open so that I can kind of push a little bit of it through if I need to get this wire straight, but then the other side is soldered down. So I'm going to try to do something similar on this side, or with the other crossed wire. There we go. I'll give those a slightly nicer touch after I don't want like a flat out cold joint, but we'll give these a touch up after trimming them. Alright, that's looking better. Get those crossed, trim it, and then 6 more of these. Or, I mean, actually it doesn't need to be 6. I only need to populate 3 of these. So let's start with the ones that are necessary in case I run out of wire. Yeah, it's possible that they only intend to have 3 of these populated, because there isn't necessarily enough wire to do all of them. I'll just cut this since it's pretty... This wire that hasn't been bent much seems to stay put all right. Oh, I wonder if there might not even be quite enough for 3. I might have to supplement with my own wire. There's 2. Yeah, this might be a little too short. wire. Oh, too short. All right, let's find something similar. I don't suppose any of these. I've got some little trimmings here from the LEDs, but they're the LED trimmings are very slightly longer, but not really. Maybe let's take these two out also, so I'm using the same kind of wire, and find something similar. Let's see, I've got some 26 gauge handy, but this feels like it's bigger. I also have some uninsulated 20 gauge. Oh, this is pretty close. Actually, the stuff from this kit might even be thicker than 20 gauge. Yeah. The top one here is the not quite long enough wire. I think it's 20 gauge. That's pretty close. Let's cut a few of these then. Much better. Alright, slightly more wire maybe. I hope I'm not cheating by using my own wire. I use my own solder though, so I think this is okay. Supply your own linear filaments. Alright, I'm just cutting roughly to length, and then I'm going to do the same thing where I solder one side and then straighten it and then solder the other side. Tuco. You're such a cat. There we go. Back to the microscope. Oh, this is cool. I don't quite have a... Yeah, maybe I'll be able to get this up on the computer in a sec. Sodium in chat is sharing a NASA document ID for some apparatus they used to put together the Cordwood circuits. So yeah, maybe when I get to a break in this, I'll see if I can search that up on the stream. They're saying that this is something that would be kind of a modular thing that you can slot components into for different setups. That's kind of what I figured they would have, like some kind of, like basically like a breadboarding or like typesetting setup for this kind of thing. Okay, those are terrible solder joints, but I just need to get these tails out of the way. Okay, let's tack down that third one. I'm used to having the board in a vise now, and it's just wobbling because it's on the side here. But that just needs to be tacked on. All right. Oops, that was not quite tacked. Okay, let's take this opportunity to do better joints on that side before these just fall out. of focus, but I think I can tell by feel that that was all right. Yeah, all right. Those should be all right. Just really don't want this to be so bent. Oops, a little overdid that. Okay, I think that's close enough to do the other side. This clearly is a passion for impeccably straight wires that I should eventually channel into a wire bending robot. I've had this idea for a while of a robot that could build circuits, kind of like a 3D printer, but instead of extruding plastic, it would be kind of bending and occasionally soldering a small wire, and then hopefully even occasionally adding, surface mount components. So if this could place a couple of, standard surface mount sizes, like, let's say, you pick like 0805s or something, and then like some 8-pin package. And then, if you picked a few packages, you could probably design circuits using only components in those packages if you really had to. And then design this robot that knows how to place those and create solder joints and bend small wires. And then you use that to make circuits that are also mechanical structures. I can imagine doing something like that on a variety of scales depending on the parts you have available. Because that feels like the kind of thing where you give it building blocks in the form of some reels of parts and spools of wire, and then you could, I guess the reason this doesn't exist right now is there's no niche for it. Like, there's no process that this is a viable method of prototyping production for. Like, it would just be its own thing, and the only way to make stuff using that construction would be to have one of these weird robots, or like buy a part from somebody who does. But it would be a little bit like a more modern version of this Cordwood stuff, where you only use it for stuff that really has a lot of density requirements, but then you end up with like this very dense three-dimensional circuit. It's kind of a nice fantasy. Like, actual design for density these days takes very different forms. And it's just like densely multi-layered everything, and chips on chips on chips on chips, and all that. I really don't like sending these flying, but I think they're pointed away from everybody. Okay, let's do that thing where we add a little more solder to make these nice. Okay, those wires done. Let's take a look at the wires on the other side. I feel like I'm kind of bookending this. Like, the left side is nice and done now. Let's work on this side. Make our way to the terrible resistor mess. Alright, let's just trim this, make these nice. is already feeling interesting, like some kind of abacus with these resistors rolling around. Yeah, I would love to try something like this with surface mount components. I was thinking about, I don't know, it's been a while since I just built something just to be like a wild, weird thing for like a contest or to be impressive for some reason. And then there's that the Hackaday 1 kilobyte challenge recently, and I've been thinking about whether to do something for that. But then I can imagine this being kind of like that too, like not 1 kilobyte, but maybe like 1 square centimeter or something, and you can just build anything you want in that square centimeter. Like that would be a really fun surface mount assembly challenge. Or not square centimeter, cube centimeter. Because yeah, you want to challenge people to build 3-dimensional circuits. I mean, at that size, power is hard. You know, either you need like really weird batteries or you need to power it externally. I can imagine some interface standard where, you know, kind of like you have the CubeSat satellites, where there's a standard for how the satellites attach to the infrastructure. I can imagine something like that for like little like hardware demos, basically, where you have a standard physical form factor and like maybe connector spacing for like power and like serial or network or something. But then inside that you can do whatever you want. But to me that seems a little arbitrary. Like, why would you want this thing to be super tiny if it was tethered? So maybe that turns into a tiny robot contest. But that's still pretty hard. Like making something tiny that's like a sculpture, it seems like a much different skill than making a tiny thing that knows how to be tossed around. Okay, those seem reasonably straight. I'm gonna resolder them on both sides. Oh. I have, there's another good couple of comments in the chat. One is talking about this, this clock that was made entirely with components. And I think I've seen that. I don't know if it was, I mean, I can't imagine that there's more than one of these in the world, so I imagine that that was the one that I've seen. Yeah. That's the kind of thing that I look at and I think, oh, how can I, like, what is my version of that? Like, what is the thing that I can just, like, sink a bunch of effort and emotion into that would become such an amazing, just condensed bit of electronic and aesthetic art like that? So it's weird. It's this thing that I find very interesting, but also kind of crazy. But maybe that's why it's interesting. I've also got a lot of diodes that I don't know what to do with. I was in such a panic, and I was doing this art project a while ago, and I thought I would end up needing a ton of diodes as a workaround for this stupid problem, and I did end up needing the diodes, just a lot fewer of them than I thought, so I still have a bunch of extras. Two-stage soldering thing where I trim it and then make it look good is a little more work, but I think it's worth it on a board like this. I'd be curious what what times tend to work for streaming for people. The problem I've been having this week, like I didn't stream at all during the week, and Certainly wasn't for lack of, or wasn't for lack of wanting to, but the thing that I'm working on for the day job right now currently is not a thing that I can stream, even though I'm recording it for later. And I'm trying to see if maybe I can change that, because there's something I'm working on that is not like I don't really see any reason why not to stream it, and so I'm trying to see if I can have a conversation about that. But either way, I got into this situation where I really wanted to stream, but it was like so late here that I have to imagine that anyone else that isn't either like in Asia or other parts of the West Coast, it would probably just be like the middle of the night. So, but I think I can be more flexible about that. Like, I was hoping today actually to start the stream kind of earlier in the day and maybe do more day job stuff afterwards, but I'm still bad at scheduling that kind of thing. Alright, so all the little through wires are in. There's one solder joint that's bothering me. It's the one that's out of focus right now. Yeah, coming back to this one. Did a terrible job before. Oh, come on. Melt before getting too over big. Oh, flux. Oh, thank you for the note that the camera stopped. I think right now I'm mostly going to be using the microscope footage, but it is nice to have this to correlate with. I'm also getting a better audio recording off of that camera right now. I've got, I mean, I think it probably has a better A to D, and I'm not recording directly from Ableton right now because I didn't think I'd end up needing much of the audio for this. But that's much better. All right. So now it's down to the components that need to be kind of lined up just right. So I think I just get to do that one side at a time. I think first I'm going to try making sure the components are about the right distance from the left side. Well, I don't know. I was going to suggest maybe doing this in two parts where I solder one side before trying to straighten out the whole thing, but I don't know if I trust that approach. I'm going to try to get them all kind of straight first. That's getting there. One of my tape flags stuck to the other LED or the other resistors. That's fine. Okay, I've got them all pretty straight, but because they do tend to move around, I'm going to have to kind of keep them straight as I solder each one. So let's start here. All right, centered. Oh, I should really putty this down to the surface, but I think I just needed to tack it like that. All right, let's stick that down and tack all of these resistors. We might actually have to end the stream a little early because my friend might actually arrive before we finish this, but I will keep you all posted. Okay, so we've got maybe 10 minutes. Got to wrap this up soon. So do a little bit more soldering, but we might have to turn this into a two-parter because I don't want to rush it. I'd rather get both a high-quality result and all the footage I need than rush it to get it done tonight, even though that might be disappointing. Got those two. Too much solder? There's a comment in chat saying something with too much solder, but it's hard to tell which one that was referring to. There are some of these where I've been intentionally putting like a dome on top, and that's certainly more solder than is necessary, but is not harmful and is just like an aesthetic choice that I'm making deliberately. And these I'm just tacking in place because I plan to, I don't want to make them hard to move if I need to. I want to make sure all the resistors are even. And then I'll make sure both sides are tacked down and then trim them and then give them a nicer finish. Okay, that's lined up, just not enough solder. Okay. Well, I think that might be the stopping point. We have to leave it at here. Let's get another shot of the progress so far. So, a little piece of putty there. Well, there's the cordwood. All the parts in, resistors tacked down on this side, and on this side just held in by the tape. All right, let's see what Tuco's doing. Well, I hope everybody enjoyed the stream, and I know this one was a little quicker and even more ad hoc than usual, but there will be a variety of different things. I'm definitely going to be doing the stream on kind of face dancer emulating USB devices soon, as well as more kind of surface mount board assembly. And totally, if you have other suggestions, let me know in the comments in the video or on Twitter. And thanks so much for watching, everyone.